Hello YouTube, this is a very brief tutorial teaching you how to change the gyro settings with the Detrum system. Specifically in this case, this is the 6C. So first you press enter, go down to model set, go down to function set, where you will find an option for something called mode. This you need to designate to a switch of your choice. In the case of the 6C, this is going to have to be the SB switch, for the simple reason this is the only switch on this radio that has 3 positions. Once your aeroplane is successfully bound to the radio, and this will only work when you've got a connection to a receiver because you can't access it without it, you press enter, you go to model parameter, go down to option number 9, and it's the same with the 8C, also option number 9, to the auto stable set, also known as gyro settings. Go down to switch set, which is number 1, at which point you can toggle your SB switch, which is what has been designated here, and you can adjust what the settings are. Gyro off is pretty self-explanatory, gyro off. Gyro 2, in normal mode, that is just assist only. The aeroplane is capable of crashing. This is meant to only assist the pilot in taking out any unpredictable behaviours of the aeroplane, whether that be through wind, stalling, or any other outside factors. Again, you can still absolutely crash in this mode, no problem. All it does is smooth out the flight. Auto recovery, which is option number 3, what that one actually does is maintain straight and level flight when sticks are released. You can just about fly in this mode, but it will be heavily restricted. This is meant more as like a panic or safe mode. To change the options at any one of these positions, you move the switch, as you see, at which point you have the option to toggle what exactly that setting you've designated is. You'll be able to tell if your system is changing settings correctly because the light will change as you move the switch. So in this case, green is gyro off, that's assist mode, that's auto stable. The easiest way to tell what gyro setting you currently have selected in your aeroplane is by physically picking your aeroplane up. In gyro off mode, the system does nothing, it's disactivated. Nothing happens, the aeroplane is strictly responding to stick commands and nothing else. In normal mode, you will see the aeroplane will fight back from outside interference on all surfaces. The important thing to notice is the surfaces do not hold, they will always return back to pretty much their normal neutral position. But when you're in auto stable mode, the aeroplane wants to return to level flight when the sticks are released. If you look at the aileron here, that's fired downwards because it wants to return the wing to a level position. The same is true of the elevator. When the nose goes down, the elevator will fire up, and vice versa and opposite. When setting up your gyro settings, to know if you have everything set into the correct orientation, the easiest way to check is by picking up your aeroplane and manipulating its axes. The surface in question should always fire into the direction of travel. So here, for example, the wing has gone down, the aileron has fired down. That's correct. If it fires up, you're going to have a problem and probably a mess on your hands. Same is true of the elevator. When it goes up, it fires upwards, and also when it goes down, it goes down, fired against the direction of travel. The rudder is exactly the same. When physically installing your receiver, it's always important to note the little aeroplane logo. The nose of the tiny aeroplane must always point to the nose, and the tail must always point to the tail. Failures to do so will basically mess up your system. You won't get the correct settings, you won't get anything in line the way that it should be. What's also important to note is the orientation of the receiver. In the case of my Typhoon here, you can see that this is set up with a, I believe this is face left setting. You can also have the receiver set on its back, which would be face up. The opposite wall would be face right, and receiver inverted would be face down. To finish off all your settings and set up your gyro completely, you have to be connected to your model again. You go into model parameter, down to option number 9, which is the gyro settings. Select that. Now we've explained what the switch set does. Now what the gains do, the roll gain, the pitch gain and the yaw gain, they're basically responsible for dictating how rapidly the gyro works on your system. Now, if you have gains set too high, that will cause an oscillation in your aeroplane where basically it'll tick too much like this and become uncontrollable. You need the system set and dialed in accordance with what the aeroplane requires. The only way you will know that is by test flying. So to edit these things, say for example, if your gain is too high and when you're in normal mode, if you're seeing that your plane flutter like this when it's at full throttle, then maybe what you need to do is turn the gain down. The way we do that, say for example the roll gain was too high here, you go down to the rate gain, which is currently set to 85, and you would reduce it incrementally, testing again each time. I would only recommend adjusting it down by say 5 or 10, retest, try again. It's always important to remember that if you get into a situation where the gain is too high, immediately turn it back to gyro off, and then the aeroplane will be okay. You can land it, adjust your settings, and go and try again. The angle gain is responsible for the auto stable setting only. Basically, this will cause the surface in question, if this is the roll gain, which would be the ailerons here, that will cause the ailerons to fire steeper, at a steeper angle. So if they just fire a little bit, but if you increase the angle, say if it was 50, it would be say there, but then if you turn it up to say 80 or 100, you'll see it fire up steeper. Again, this only applies to the auto stable settings and not the normal mode. Only the rate gain applies to the normal mode. Continuing down the settings, so past the gain options, you can also, to recall this, you can also, if a surface is firing in the wrong direction, again it's firing into the direction of travel, not against it, then you must reverse the relevant gain in question. For ailerons, it's the roll gain. For the elevator, it's the pitch gain. For the rudder, it is the yaw gain. You also have something called roll offset and pitch offset. Now basically what this does is this is for auto stable only. If you find when you put your airplane into auto stable and say it starts to dive, you might find that you need to adjust your pitch offset. And again, you will have to test that on the ground, observing the surface in function when it's in full auto stable mode. We also have down here the mounting, which we talked about earlier. In this aeroplane that I'm currently connected to, the receiver is face up, therefore that's up, as opposed to face left, face right, or face down. The wing type you won't adjust, we always use normal, and that completes all of the settings there. So if you do find that once you start to fly your aeroplane with the full stable mode engaged, the plane has a tendency to roll slightly or dive or pitch up, then you'll have to trim the gyro. So you'll go and look at your offset on your roll axis and the offset on your pitch axis, and we can have a look. Say for example, with this aeroplane here, this is the Typhoon. If we engage the auto stable, now currently the tail is pointed slightly down, so we would expect the surface to slightly point down, which is exactly what it does. Now say for example in level flight, this was, say, slightly up or slightly down. Say, for example, we wanted that there to stop pointing down as much as it is, so the aeroplane flies more level. Is you'll edit the number on your pitch axis, and it'll look like this. So if we try it one direction, we bring the surface up in the one axis, or we can go the opposite way and bring it down, depending on what the characteristic of the aeroplane in question that you're working on. Remembering that you always want the surface to fire into the direction of travel. So if the tail's going down, the elevator should also point down. If the tail's going up, then the elevator should point up.